Hi, boys and girls. Bless you. This is Mrs. Twisdale. Bless you. Today's our last lesson in Chapter 13. We're doing misleading statistics. Our objective is I can recognize a misleading statistic in a real-world problem. A lot of it today is also not only misleading statistics, but just a couple of real-world problem solved story problems. So what does misleading mean? Misleading means to give a wrong impression or trying to deceive you. So deceive means to trick you. So see this picture? If you were up on the surface, you would see this fin, which looks like the fin of a shark. But the bottom, it's actually just a fish with a shark fin strapped to it. It's trying to trick you or give you the wrong impression. Here we have the McDonald's Big Mac. This is what you see on the commercials. That's what you actually get. It's trying to trick you. It's trying to deceive you or give you the wrong impression. Here we have a dog wearing a bag that looks like a cat's face, and the cat's very confused because it's been misled. So sometimes we have statistics that try to mislead us, and oftentimes you will see this in like the news. Someone will take the statistics and they're technically correct, but they didn't really pick the best measure of center or measure of variability, and so it kind of will trick or mislead us. So let's go to this first problem. Now, Mr. Owen, he wants to move to a town where the daily high temperatures is in the 70s most days. I'm going to pause for a second. Now, you're looking at this page going, Mrs. Twisdale, I am not going to write all that down. I don't expect you to. But just show your work on this one, okay? I know it's kind of a long one, okay? So he wants to live in a town. Felicity. She's just talking. Hey. He wants to live in a town where the daily high temperature is in the 70s most days. So pretty good temperature. But in the high 70s, right? So you want to make sure it's the high 70s. A real estate agent tells him that the daily high temperature in a certain town is 72 degrees. That the average. Other statistics about the town are given in the table. Does this location match what Mr. Owen wants? Why or why not? So, we're going to use this graphic organizer to help us. First of all, what do I need to find? I need to decide if the daily high temperature in the town matches, I'm looking at this part right here, matches what Mr. Owen wants. And he wants a high of 70s. If it matches and is with the high of 70s most days. What information do I need? I need the data in the table. Okay. So, how will I find the information? I'm going to work backwards using the statistics to draw conclusions about the temperature, or about the blank of data. I would say probably about the measures of data. Sometimes I don't know what they want me to write there. Okay, so taking a look at this, I think what's happened is the person trying to sell him the house, the real estate agent, he's telling him what he wants to hear. Have you ever worked with a salesperson? Felicity. Have you ever worked with a salesperson that just tells you what you want to hear? They try to mislead you or trick you so that they can make a sale? So sometimes people are trying to sell us something. They use the statistics to make a point, even though it's not really fair. It's not really accurate. They're just trying to trick you, okay? So let's take a look at the minimum height temperature is, looking at my chart, is 62. That's pretty cold. Whoa, that's not what I want to do. Here we go. Minimum is 62. Now the high temperature is sometimes less than 70. The maximum high temperature is 95. That's pretty hot. It's sometimes greater than 80. And the median of the data set is 69 degrees. Okay? The median is the middle values of the data set. Because the median is 69, it's less than half of those days must have high temperatures less than or equal to 69 degrees. So it sounds like that most of the time it is 69 degrees. And that mean is showing 72 because it had an outlier of 95 degrees, but this is actually, the real estate agent it doesn't really match. So it does not match what Mr. Owen wants. Because that median shows that half of the days are less than 69 degrees, which is too cold for him. Does not match what he wants. Because of that median score is actually a better indicator. So, Abigail, the real estate agent was trying to trick him. Okay? So let's go ahead and try this next one. A store collects data on the sale of DVD players each week for 3 months. So here we have weekly DVD player sales, minimum week, maximum, lower, and upper quartile. The manager determines that the data has a range of 62 players and decides that the weekly sales were very inconsistent. Use the statistics in the table to decide if the manager is correct. Now, this word inconsistent means that sometimes it was really high, sometimes it was really low. It wasn't the same each week, and that's what we really need to see. Okay? So what I'm going to first look at is on 1 week, the lowest number of sales was 16, and on another week, the upper number was 78. But take a look at this lower quartile, 58 and 72. So most of the sales, I'm just going to draw like a little diagram to show you. We had a 16 and a 78 as our whiskers. But most of the sales fell in between 58 and 72. Most of them are right in there. Okay? So if you can see, it looks like they had just one bad week. So I would say the manager is incorrect because most of the sales were, because that's that inner quartile, right? Most of the sales were clustered together. Remember that word clustered means close together. And we just had a couple of outliers. And just had a low outlier. Now remember, when you explain your reasoning, it doesn't have to be exactly what I said. It just needs to be in your own words. Explain it so that it makes sense. Okay? Now, here's a try it problem. These ones you should be able to do on your own because these are actually going to be using a lot of the skills you've already done. So here we have Susanna. She wants to buy a fish. Now her fish, she wants it to grow to be 4 inches. Okay? So Mark suggests she buys the same type of fish he has. He has 5 of these fish with the lengths of 1 inch, 1 inch, 6 inch, 6 inch, and 6 inch, with the mean length of 4 inches. Should Susanna buy that type of fish that Mark suggests? Explain. Okay? So I want you to say yes or no and why she should or should not buy that fish. Go ahead and do this on your own. Okay, so I'm sure that you came up with some good way to explain this on your own. I'm going to just draw a little bit of a picture. So Mark's like, well, my fish is on average 4 inches because I have one fish that's 1 inch. These are my little fishes. Another fish that's 1 inch. And I have 3 fish that are 6 inches. Whoop. These are my very funky looking fishes. Now, Susanna just wants a 4-inch fish. She doesn't want a 6-inch fish. She doesn't want a 1-inch fish. So it sounds like this would not be a good type of fish for her because the average is not really a good measure. So no, because because his fish are not actually 4 inches. I bet maybe he's got 2 baby fish and 3 adult fish, but I don't know for sure. Actually 4 inches. This data is misleading. A better way we should have done this data would be with the modes. Okay? So that's how I would have answered it. I don't think yes would have been the right answer, but if you had a different explanation, that's fine. Okay, try this one on your own. This is going to go back to mean absolute deviation. So if you can't remember how to do that, you might need to go back in your notebooks. I think it was lesson 13.3 and 4. Okay, so the table shows the daily high temperatures in degrees Fahrenheit recorded at Chase's school last week. What is the mean absolute deviation of this data set? Okay, so go ahead and find this answer, and then I'll solve it with you. Okay, so because I couldn't actually remember how to solve the mean absolute deviation, I went back to lesson 13.3 and I pulled this from the video. So here's the steps to find the mean absolute deviation. Step 1, we need to find the mean, unless the problem already told us. Well, it didn't, so I need to find the mean of the data set first. I'm going to use my calculator and find the mean by adding up 70. Oops, where's my pen? Okay, 70, 74 plus 68 plus 69 plus 68 plus 68 plus 73, and I'm going to divide it by 1, 2, 3, 4, 5, 6, 7. So that's going to give me the mean. So I solved that and it gave me a mean of 70. Step 2 is I need to find the distance of each number from the mean. So I'm going to take this number 70 and I'm going to write a new data set right here. So 70 is 70 from, it's 0 from the mean. And then 74 is 4 points from the mean. 68 is 2 points from the mean. 69 is 1. 68, that's 2. 68, that's 2. And 73, that's 3. So that's step 2. I already did step 1. Step 3, find the mean of these distances by adding them up and dividing them by how many you have. So I have 0 plus 4, 4, 5, 6. So I'm just adding these up. 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14. And then it says divide by how many there were, which 1, 2, 3, 4, 5, 6, 7. 14 divided by 7 equals 2, which is simplify. And that is one of our options. So our answer is B. Okay, now if you have any questions on this, this is from lesson 13.3 and 4. Now this next one you're going to solve on your own. Which of the following data sets could be represented by the box plot below? Go ahead and solve this on your own and just answer A, B, C, or D. Alright, so to solve this one, I quickly noticed that, well, my lowest point would be 10, so I looked to see if any of these did not have a 10, and D didn't have a 10, so I crossed that out. Then I looked to see, okay, my highest point was 80, or any of them not have 80. A has an 80, B does not, so I know that's not an option. Then I looked to see, well, let's line them up and find the median. So 10, and then I was just putting these in order so I could find the median. 30, 60, 60, 80. So in A, our median is 60. Well, that matches up, so A is still a possibility, but let's see if it's the right answer. Then 10, 20, I'm just putting C in order, 60, 70, 80. Look at that, our mean is also 60. So then I had to look at my lower quartile of the first one was 20, and that one matches 20. My upper quartile was 70, that one matches. A is not the right answer. C was the correct answer. Hopefully you got that one correct. Last problem. The data set below shows Mr. Long last 6 bowling scores. What is the range of the data set? Pause and answer. Try it on your own. Okay, to find the range, I just took his highest score of 189 and his lowest score of 148 and subtracted them, which gives me 41. Oops, I guess I should have colored in the bubble. Alright, so that was just a basic review and also discussing misleading statistics. And we are all done with chapter 13. Woohoo! Which is actually the last chapter in the math book. Okay, so be proud of yourselves. You've worked hard. I hope you guys have a great day of learning, and please, please, please ask me if you have any questions. Thank you. See you later.